Hi, today we're going to be looking at this DC power supply which was provided to me for this review by Ekins on AliExpress. So I'll put a link down below for the listing for this particular item, but I'd been looking for a relatively wide voltage range power supply for a while, and normally I'd buy something like a TTI power supply, but they are quite pricey for something that's probably going to be of occasional use, and there are other voltage ranges available. But this particular one is a 0 to 120 volt DC output at up to 3 amps, so really wide voltage range. And the kind of things that you might want to use this wide voltage range for are things like power amplifiers and that kind of thing. So since we're going to be developing some audio kit later on in the year, I thought it might be useful to obtain a power supply like this that can drive relatively high output voltage, so that we can drive some speakers and that kind of thing without needing to immediately power it up with a big power transformer. So this is very keenly priced. I think it's about £45, so a really good price for something like this with a voltage range and current range of this nature. Although the actual device itself is very basic, so you really have just the voltage control here and the current control, no preview. So in order to set the current, you have to short the terminals and set the current up to the limit that you want, and then remove the short and use it as you'd like. So pretty basic operation, a bit like the old school lab power supplies. And this is also a really compact unit, so a really nice form factor. It's about 120 millimeters high by 70 millimeters wide, and then I think it's about 150 millimeters deep. So really nice form factor, fairly lightweight, so it's obviously got a switch mode converter in it. But yeah, really nice little power supply. On the back here, we've just got a fan and an IEC connector. So let's power it up and have a look what it's like. Right, so we've got the Fluke 87 hooked up to the output, so let's turn it on and see what happens. Alright, so you saw we've got a little bit of an overshoot there when you first turn it on. That's with no load, by the way, so it might not be quite so pronounced when you've actually got a load connected. And then on the front panel you can see we've got our voltage reading, our current reading, and then also the amount of power that's being drawn. So let's see how the voltage tracks. So we've got 13.2 and 13.25, it's sort of settling around to on the Fluke 87. 21.6 and 21.68. 35.6, so that's tracking quite well. 49. Pretty much 49 on the dot. 87.2, 87.3. And then the maximum voltage at the moment is 122 volts and 122.3 on the meter. So that's reading pretty much spot on. So I have got a 100 watt lamp here, which was from the lighting project. So let's see how it behaves when we've got a load connected. Right, so we've got a few bits of equipment connected now. We've got our Fluke 87 reading DC voltage. We've got our Rigol reading the AC component of the output of the DC power supply, and also the Fluke 289 reading the AC component. That's in millivolts, so it's flickering somewhere between 8 and 15 millivolts AC on the Fluke 289. And then we've got our 100 watt lamp connected to the output as well. So it's looking quite noisy at the moment here, but at 0 volts it's probably entering some kind of pulse skipping mode or something, which is giving us a little bit of extra noise. As soon as we start to turn up the voltage, you can see it settles down to something much more reasonable. So we're reading about 8 millivolts AC as ripple, and that looks to be pretty similar on the Rigol. Let's turn up the voltage some more. And you can see we've got our power reading, so we're drawing about 5 watts at the moment. The noise has gone up very slightly to 19 millivolts AC, and you can see that is reflected on the Rigol as well. Turn up the voltage some more. We're drawing 17.8 watts now, and the noise is sort of around 10 to 15 millivolts AC, and that looks fairly similar on here. I think the large changes that you're seeing here are just the potentiometers. There's, if you get a little bit of noise, it takes a bit of time for it to settle. And then at maximum voltage here, reading about 20 millivolts AC again, drawing 34 watts. The lamp's reasonably bright now. And this all looks fairly consistent, so that's about 1 division, which is 20 millivolts. So that all looks fairly reasonable. It seems to be doing its job. I can't actually hear the fan spinning. I'm not sure if it is going at the back, but there's certainly no noise that I can hear from the power supply at the moment. Right, so similar to most of these power supplies, it's got the folded metal frame, the plastic front panel, so fairly standard in construction. Let's have a look inside. Right, so we've got what appears to be a fairly conventional arrangement for a DC power supply. So we've got a switch mode power supply which is doing the bulk conversion, at the high power. And then we've got some analog electronics here which is doing the fine control and also a little bit of regulation after the fact. But basically what we've got is our IEC inlet at the back here which is fused. It's all lugged to the chassis with crimp terminals and everything, so pretty decent there. We've got our leads that come from the IEC connector to a hard power switch on the front panel, and then that goes into this AC filter. So we've got a PTC here to limit the inrush current. Then we've got a series of capacitors, common mode choke. We've got a couple of little capacitors here, and then another larger one here, and then we've got our bridge rectifier. And then we've got 2 large capacitors on the main side, so this is doing the rectified DC. So we've got a couple of 560 microfarad capacitors here. And then we've got our actual converter here. So here we've got the Power Integrations TNY274, and this is a self-contained switch mode power supply controller. So these are fairly common devices. Power Integrations are a massive company that designs switch mode power supply ICs, so no surprise to see something like that here. And that's a good sign because these are really good chips and they're pretty reliable. So we shouldn't really have any troubles in terms of reliability in terms of this power supply. And then we've got our big transformer which is doing the main conversion here, and then we've got some filtering, our output power capacitors, we've got our current shunts here, and then another capacitor at the output, and then basically we've just got some analog control here. So we've got a quad op amp here and another op amp here which is doing the feedback, so it'll be reading the current, controlling the voltage, and then it would appear that the bulk of our conversion is being controlled by a transformer here, and then we've got another transformer which is providing this with some coarse DC voltage. So no optocouplers in this design. We're actually using transformer feedback to control the set point of the Power Integrations DC to DC controller. But the build quality looks pretty good actually. I'm quite impressed. We could have done with a bit more than the little bit of elastic on the inductor here, which is just stopping that wobbling around. But there's nothing on any of these, but it did survive shipping from China, so no problems really with the build quality from what I can see. Let's take a look at the front panel. Right, so the front panel is fairly interesting. Driving the actual whole system, we've got this little Nuvoton microcontroller, which is a 8051 based little 8-bit processor, but it's offloading things like the multiplexing of the displays to this Titan Micro TM1640. And if you watch my video on the IKEA kitchen, I used the smaller version of this, the TM1637, to drive 6 7-segment displays. This one can drive up to 16 7-segment displays, so quite a lot more, and that's obviously offloading all of the driving and all of the multiplexing from the microcontroller. It doesn't need any extra transistors or anything like that, so that's really a nice little integrated chip, and that just communicates with the 8051 processor through a serial interface. Then we've got a little bit of voltage regulation, so it's taking in voltage from the main board, regulating it down to 3.3 volts, filtering it with this capacitor, and that's sort of driving the logic. And then just above the microcontroller we've got our adjustment potentiometers here, so our setting for voltage and current, so very easy to calibrate if you needed to. These are really accessible, you can just tweak them once you've connected a precision multimeter to the front panel. And then just hiding at the bottom of the unit we've got the binding posts, which are connected via some crimps, some fairly heavy gauge wiring which goes straight to the PCB. Surprisingly no capacitor across the binding posts, but with the fairly heavy gauge wiring the additional impedance is going to be fairly low, and it's not really a precision power supply, so it's not going to need that on the front panel. But these binding posts are very easily replaceable, and I might change these for the safety type because I don't tend to have the 4mm connectors that plug in like this. Most of mine are the safety type, so I might swap these out. So we have got a fan at the back of the unit, and it looks like it kicks in when the heatsink gets warm. There's a little diode sitting at the bottom here on the heatsink, and that will be used to measure the temperature on the heatsink to determine when to turn on the fan. So it's nice that that's not running the whole time. You know, the fans can get a bit dreary if you've got all your equipment running, especially when not needed. So I think that's about all there is to report on this power supply. It certainly seems to be pretty good value for money for the price. Build quality is absolutely fine, so no complaints really, and we're using some decent parts. So the power integrations DC to DC converter is a really high quality piece of kit, and also everything is very easily serviceable. So rather than having one of those really annoying hybrid modules that's plugged into the board, you know, perpendicularly, you see them all the time, it means that if anything goes wrong, you're absolutely stuffed and you can't do anything with it. All of this is perfectly serviceable, so that's a nice little thing. If you wanted to upgrade the capacitors, you could do, but not really any complaints for the price. Cheng is a perfectly acceptable brand. It's in a lot of consumer hardware, so I'm not really going to complain about the fact that they're not using Panasonic or Rubicons or something like that. But overall, it all looks okay. So if you want to take a look at the product listing, I'll put it in the description down below. It would also be useful if you had a look at the AliExpress page and let me know if there's anything that you're particularly interested in, because there might be an opportunity to look at some more equipment from the Ekin store on AliExpress. So hopefully you found that video useful. If you are looking for a DC power supply that's low cost and quite small, this is certainly worth a look. It's a very nice form factor, and they do have the different versions available, so there's various different voltage and current combinations that you can get. And yeah, this is really keenly priced. So if you enjoyed the video, give it a thumbs up, leave some comments down below. It's always nice to have some feedback, and until next time, thanks for watching.